so apparently the microphone is on now. Let's try this again. Sorry that it didn't work. Okay, so we're going to start our new unit today and Wednesday. We're going to be doing our right triangle trig. So far, you guys, hopefully, back in geometry, you learned sine, cosine, and tangent. Today, we're going to learn secant, cosecant, cotangent, and what that means. But first, we need to review a little bit from geometry. So sine is our opposite side divided by our hypotenuse, or so. And then we had C is cosine, adjacent over hypotenuse. And that was our ka. And then we have tangent is opposite over adjacent. And that's toa. This one was an A. Okay? Those all have to do with the relationship of a specific angle, and it could be A or B, but this time we picked A. You know that because I have this theta here, and if you look over on this side, it does find the sine of theta. So you want to use this. Theta, you can draw like that. You can make a circle and just put a line through it. It's read theta. It's just easier than saying the measure of angle BAC or the measure of angle ABC, wherever you try to draw it. Okay? Now, in a triangle with your thetas, the side across from the theta is your opposite side. The side next to your theta is your adjacent side. Your opposite and adjacent always touch the right angle. They're the sides of your triangle. The longest side, or the one across from the right angle, is your hypotenuse. The theta will change sizes. So again, I'm going to put this up here in the name section. If I draw another right triangle, if I put theta up here, that puts my opposite down below, my adjacent to the side, and my hypotenuse over here. Okay, so depending on where your theta or the given angle that they want you to find is, you have to move around your opposite and your adjacent. Your hypotenuse will always be approximately at an angle. I could even draw the triangle upside down like this and put the theta down here. And so then the opposite would be up here, the adjacent over here, because there's my right angle, and the hypotenuse, would be there. And so the triangles can go anywhere, really. Okay? All right, so again, sine is your opposite side over your hypotenuse. Your cosine is your adjacent over your hypotenuse. And your tangent is your opposite side over your adjacent side. Okay? So before we learn what those other funky words are, let's look at one triangle. Okay, so if I find the sine of this triangle down below, it says find the 6 trig functions for angle A. So I'm going to put my theta right here just so I make sure I know which side I'm looking at. So that makes 15 my opposite side. My hypotenuse is 17, but I have no side down here. I have to use Pythagorean theorem. X squared plus 15 squared equals 17 squared. Remember, in Pythagorean theorem, the two pieces that touch the right angle are also the ones you add together. Okay, so those are your opposite and your adjacents. So I get x squared equals 17 is 289. I would have to take 15 squared, that's 225, and then move it to the other side, so minus 225. So I get x squared equals 64. So this side equals 8. Okay, so I can do my sine of 15 over 17. My cosine is 8 over 17. And my tangent is 15 over 8. Okay, so for these other 3 new angles, these are really just the reciprocals of your originals. So S and C go together. When you think of sine, cosine, tangent, you always say sine and cosine. There's an S and a C. When you think reciprocals, there also has to be an S with a C word. So sine goes with cosecant, and it's just sine flipped over. So it's hypotenuse over opposite. Cosine goes with secant, because this is C, this is S. So this one's flipped over, hypotenuse over adjacent. And tangent and cotangent, that's pretty easy. They're just the same thing. So adjacent over opposite. So there's no trick. If you see the word tangent, cotangent, they go together. Okay, so down here in example 1, you can flip sine over and you can go 17 over 15, or you can think of it as the opposite in our triangle. So instead of taking opposite over hypotenuse, we would take hypotenuse over opposite. Okay, so a sine is 15 over 17, cosecant is 17 over 15. You'd have to do the opposite of your sine. Cosine goes with secant, so I would flip this over, 17 over 8. And tangent, cotangent is its reciprocal, so 8 over 15. Okay. Now this next one, find the remaining 5 trig functions. It says sine of b is 4 over 5, so I can write that one in there. I don't have a triangle, so I'm going to draw my triangle. I usually draw the same one, just keep things always in the same spot. So if I go A is here, B is here, C is here, my theta is up here this time. So sine is my opposite hypotenuse, and then I'd have to do Pythagorean theorem to find this side. So I have 4 squared plus x squared equals 5 squared. So if x squared equals 25, I'd have to move that 4 over squared, which is 16. X squared equals 9, so x equals 3. We're not worried about the positive negative on this. It's a triangle, so we only want the positive. So that side's 3. So now from here, my adjacent would be 3, and my hypotenuse is 5, 3 over 5. And my tangent is opposite adjacent, so I would have 4 over 3. And then to do my reciprocals, I'm just going to flip these over. So 5 over 4, 5 over 3, and 3 over 4. Okay. These next ones are a review from geometry of how to solve. Okay. So first off, we need to make sure that our calculator, we need to hit the second button. Scratch that. You need to hit the mode button, and on this screen, the second row says rad, degree, whatever. You want to make sure that the degree is now the one that's filled in. You want it to be in degrees. Okay? All right. So now when we look at this triangle, again, we're going to use SOHCAHTOA to figure out the relationship in my triangle. So I have an angle and I have opposite, adjacent. So this one is tangent. I'm just going to write cosine. Oops, can't write anything here. So tangent of 37 degrees equals x over 3. I need to multiply by 3 on both sides to get that tangent by itself. So I have 3 tangent of 37 degrees equals x. So in my calculator, I'm going to hit 3 times tangent, and then hit 37, and that will give me my answer. And I'm going to cheat and go look really quick what that answer was, 2.6. So we get x equals 2.26, and it said to round to the nearest hundredth for the sides and the nearest degree for our angles. Okay, so I'll catch up with that piece really quick. Okay. All right, so this next one, I'm going to change colors so it's a little easier to see. Now I'm going to go opposite hypotenuse, so that's a sine. So I have sine of 24 degrees equals 4 over x. And to get that x by itself, I would put sine over 1 and cross multiply. So x sine of 24, that's really messy, sorry. X sine of 24 equals 4. But now I want to get x by itself, so I'm going to divide by sine of 24 on both sides. So x equals 4 over sine of 24 degrees. Okay, so since that is division, you could have skipped these 2 steps here in the middle, or this big step in the middle. if you realize that that x and the sine of 24 are going to skip, you can go straight to writing it like this if you want, if you remember that trick back from geometry. That's great. Okay. Remember that when you use sine in your calculator, that it really does like parentheses. So 4 divided by sine of 24, end your parenthesis, and you get 9.83. Hopefully you can see the square. Okay, so now we're going to go opposite and 15. We have opposite and hypotenuse. So we have sine, but this time we don't know our x. We don't know our degrees, but we know that that's equal to 12.5 over 15. So to break sine and x apart, just like back in matrices at the beginning of the year or last year, you have to use the inverse button to break these two apart. So what that's going to end up looking like is x equals sine raised to the negative 1 of 12.5 over 15. So in your calculator, come down here and show you that. So we want to hit second sine. So when you do that, it puts sine raised to the negative 1 in your calculator. And now you can put your 12.5 divided by 15, your opposite, over hypotenuse. And you get, and remember, since we are doing a angle here, we just need x equals the degree to the nearest degree. So 56.4 would really mean x equals 56 degrees. When you hit pre-calc, if you take pre-calc, they'll want you to be more specific and exact, probably 1 or 2 decimals, but for now, we're just going for 1. Okay, so for D, we have this side, which is the one touching it, so it's our adjacent. This is our hypotenuse. So this one is going to be cosine of x equals 16 over 20. So x equals cosine inverse, or inverse cosine. So now inverse cosine of 16 divided by 20. And we get x equals 36.8, so really 37 degrees. Okay? So that is each piece of the solving. Please draw your triangles on your hands and seeing your exit slips. If you have questions, please email me now that I've got sound to this. Email me if you have any more issues, or use Remind. I have signed up in Remind. We have a class in Remind. You can zap me through there too. Have a great day.